Good evening everyone, good evening. I welcome you all again to JEE Enthuse. I hope all of you are doing great, having a good time. So people, we are meeting after so long, yeah? So let me know quickly in the chats if I'm perfectly audible and visible to everyone before we start the session, my dear people. Let me know quickly in the chats if I'm perfectly audible and visible to everyone. Hello Insha, hi Shri Watson, hello Aisha, hi Ashwarya, hello Manisha, hi Nandini, good evening, hello Farah, hello Afshan, hi Darshani, welcome back, all my lovely students, welcome back, hello Falak, welcome back everyone, welcome back. Quickly let me know in the chats if I'm audible and visible to everyone, my dear people, yes? Perfect guys, perfect. So, as you all must be knowing, tonight we are going to do the most expected questions from the chapter Thermodynamics, right? Perfect. So before starting tonight's discussion, the ones who have just joined in, the ones who are new to the channel, let me quickly introduce myself. So people, my name is Wassim and I'm your chemistry master teacher right here on this JEE Enthuse channel, right? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this particular JEE Enthuse channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well, okay? So let me know first in the chats if you all are super duper excited about the tonight's session, my dear people. Yes, as you know, your JEE Mains 2022 dates are out, right? Now it's going to be the time to gear up the preparation phase. Right, people? So let me know quickly in the chats if all of you are super duper excited about the tonight's session, yeah? Perfect, guys, wonderful. How many questions? There will be around 25 to 30 questions which will be solving in the tonight's session, right? And I'm sure by solving these questions, a lot of things will get clear to you from the chapter Thermodynamics, right? Perfect. So let's get going then. Let's get started with the first question which is on your screen, which is a very simple and the basic question based on the first law of thermodynamics. Let's exactly get to know how to solve these type of questions, right? Let's exactly have a look how to solve these sort of questions. See guys, what the question says exactly, a system expands from 5 liters to 10 liters. A system, which is basically your ideal gas, it is expanding from 5 liters to 10 liters. That means the initial volume of the gas is simply 5 liters and final volume of the gas after the expansion, it's equal to 10 liters. A system expands from 5 liters to 10 liters against a constant external pressure of 2 atm. Against a constant external pressure of 2 atm. Well, it's mentioned in the question that the system is showing expansion against constant external pressure. So this process is supposed to be irreversible, right? Whenever expansion or compression takes place against constant external pressure, the process is supposed to be irreversible. Number one. Number two, if it absorbs 800 joules of heat. So during the expansion, system is absorbing 800 joules of heat. Whenever heat is absorbed with the system, Q value is taken to be positive. Calculate the value of delta U during the process. We need to calculate the value of delta U. Very simple and basic one. So people, I'll be using the first law of thermodynamics. As per first law, delta U is nothing, that's equal to Q plus W, right? Now the first thing which I'll be calculating the value of W during this irreversible expansion, which is simply going to be equal to minus P external delta V, which is V2 minus V1, right? Minus times P external. External pressure is given to me as 2 atm. V2 minus V1. V2 minus V1 will come out to be 5 liters, right? So the value comes out to be minus 10 and its units are going to be atm liter, right? Because the pressure which I've used over here, it's in atm, and change in volume, it's going to be in liters, right? Now people, since we need to calculate the delta U value in joules, right? I need to calculate the value of delta U in joules. It's going to be equal to Q. Q value is already given to us in joules, which is plus 800. I'll be writing its units with it so that you don't get confused. Plus W. W is basically equal to minus 10 atm liter. So I'll be converting this W into joules. Do remember 1 atm liter is equal to 101.3 joules. 1 atm liter is equal to 101.3 joules. So this value comes out to be 1013 joules with the sign minus. So I'll be using the minus sign over here, which is going to be 1013. Now the value comes out to be in joules, right? Just solve it, get the value of delta U, which we were supposed to calculate. Very simple and basic question, my dear people, right? So after solving, what is the final answer which you'll be getting? The final answer which you'll be getting is going to be minus 217 joules, right? So the final answer of this particular equation is going to be minus 217 joules. So during this expansion of the ideal gas, internal energy of the system is decreasing, right? Delta U is coming out to be negative, right? Which is exactly minus 217 joules. Perfect. Simple and basic it was. Moving on to one more. A sample of ideal gas is expanded from 1 meter cube to 3 meter cube in a reversible process for which P is equal to kV square, right? K value is given to us, work done by the gas will be. Again, the very simple question. In the question it's mentioned that the gas is showing reversible expansion from 1 meter cube to 3 meter cube, right? The gas is showing reversible expansion. And you guys must be knowing, during the reversible processes, how do we calculate work? Work done in reversible process simply equal to minus integral, it's going to be P gas multiplied by dV, right? Under the limits, initial volume to final volume. This is something which every one of us would be knowing, right? This is the pressure of the gas which I'm taking in this particular integral right here. Yeah. So I'll be simply writing it W reversible as minus integral V1 to V2. What is V1? Initial volume, that's 1 meter cube. Final volume is 3 meter cube. What is P value? P value is given to us as kV square. It's given to us as kV square multiplied by dV. Perfect. So I'll be taking this K out. Integral of V square, it's simply going to be equal to V cube divided by 3 under the limits 1 to 3, right? So it's going to be minus times K value. K value is given to us as the equation, which is 6 bar per meter raised power 6, right? K value is equal to 6, right? Minus was in the beginning. It's going to be divided by 3. Take the 3 out, right? Upper limit minus lower limit, it's going to be 3 raised power 3 minus 1 raised power 3. Just solve it. That's going to be the final answer of the question, people. Isn't it? Very simple and basic, right? I just used the formula, right? W is equal to minus integral V1 to V2, which is going to be P dV, where P is the pressure of the gas. The gas is following this particular equation. P is equal to kV square. K out taken out. Integral of V square. V cube upon 3. Give the upper limits, give the lower limits. Get the answer. Get the value of what? Get the value of W. So after solving this part, W value you'll be getting as minus 5200 kilojoules exactly, right? Simple. Very simple and basic question, right? Let's move on to one more type of the question. Which of the following is correct for the following exothermic reaction carried out at constant pressure? So this is basically, as per the question, we are given with the exothermic reaction. If it is the exothermic reaction, definitely during this process, heat will be getting released, and whenever heat gets released, Q value is taken to be negative. So for this process, Q value is going to be negative. Point number 1. Q value is negative. So this cannot be the answer. This cannot be the answer because it's an exothermic process. Number 1. Number 2, guys, have a look. On reactant side, if I ask you how many total moles do we have? This is 1, this is 3. On reactant side, 3 plus 1 comes out to be 4. The total gaseous moles are 4. On the product side, we have got 1 plus 1, 2 gaseous moles, right? Okay. So basically, when this reaction is happening, are the number of moles during the process increasing or decreasing? Number of moles are decreasing. If number of moles are decreasing, what is going to happen then? What is going to happen, people? See, at constant pressure and temperature, you guys know volume is directly proportional to moles. If number of moles are decreasing, volume will be decreasing. Decrease in the volume is something which we call as compression. So during this process, can I say compression of the system is happening? And whenever system undergoes compression, work is done on the gas, and we say W value is taken to be positive in chemistry. So W value is going to be positive. W value positive. But over here it's mentioned W is negative. It cannot be the answer, right? Now the answer is either A or B. Okay. Now what I'll be doing exactly, I'll be first of all calculating delta Ng for this particular reaction, which is going to be equal to number of moles of gaseous products, which is 1 plus 1, that's 2, minus number of moles of gaseous reactants, which is 1 plus 3, that's 4, So 2 minus 4 comes out to be minus 2. So delta Ng for this particular reaction is minus 2. Well, if you got the delta Ng, you can write the relation delta H is equal delta U plus delta Ng RT, right? So you'll be getting something as delta H is equal to delta U. Delta Ng is simply minus 2 RT. So from this particular equation, is delta U coming out to be equal to delta H? No way. I can say delta U will be equal to delta H plus 2 times RT, which clearly tells you delta U is greater than delta H. So this is going to be the answer of the question. Delta U is greater than delta H, right? Perfect. I'm sure this is clear to every single guy. Right, people? Let's move on quickly to one more particular question. Look at this question, people. The heat of combustion of benzene in a bomb calorimeter, where volume is kept constant, right, was found out to be 3263.9 kilojoules per mole at 25 degrees centigrade. Calculate the heat of combustion of benzene at constant pressure. So basically, heat of combustion of benzene at constant volume. Heat of combustion of benzene at constant volume, which I represent with QV. That's given to me, right? As you all must be knowing, QV is nothing. That's equal to delta U, right? And delta U value basically is given to you, which is 3. It's going to be 3263.9 kilojoules, right? Since during the combustion is always an exothermic process. If it is exothermic, heat will be getting released. So delta U sign will be negative, right? What do I need to calculate? I need to calculate the heat of combustion of benzene at constant pressure. As you know, QP, which is the heat exchange between system and surroundings at constant pressure, that's basically equal to delta H. This is something I need to calculate. This is something I need to calculate. First thing, I will be writing the combustion reaction of benzene. I'll be writing the combustion reaction of benzene. Make benzene to react with oxygen. It is absolutely going to lead to the formation of carbon dioxide. And with this, you'll be writing water as well. This is going to be the combustion reaction of your benzene. Right, people? So the first thing which I'll be doing over here, I'll be exactly balancing the reaction, right? I'll be exactly balancing the reaction. Let's try to balance this particular reaction. Have a look. It's a simple way to balance it. There are 6 carbon atoms, so make it 6 carbon atoms. 6 hydrogen atoms, so make it 3 times, right? And the stoichiometric coefficient of oxygen is going to be 6 plus 6 divided by 4, right? So it's going to be 2, 3, 2, 2, 6, 2, 12, 12 plus 3, 15, 15 divided by 2, right? So 15 divided by 2 is going to be the stoichiometric coefficient of this oxygen over here. Well, you balance the reaction. How do we balance the combustion reaction basically? There is a general procedure. Do remember it. CXHY plus O2, it always first of all gives carbon dioxide and water. How do we balance this sort of a reaction? This is X, make it X times. This is Y, makes it Y by 2 times. And the stoichiometric coefficient of oxygen is going to be X plus Y divided by 4. As simple as that, right? This is the way you balance it. When you balance it, after this I'll be getting the value of delta Ng for this particular reaction. Delta Ng is equal to number of moles of gaseous products, which is 6, minus number of moles of gaseous reactants, which is 15 divided by 2. The value comes out to be minus 3 by 2. So delta Ng value you got. Well, after you get the delta Ng value, you'll be using the relation delta H is equal delta U plus delta Ng RT. Well, as per the equation, delta U is given to me in kilojoules, right? Which is minus 3263.9 and the units are in kilojoules. Perfect. Plus delta Ng value, it is minus 3 by 2. R value, 8.314 joules per Kelvin per mole. Temperature of the system must be given to me 25 degrees centigrade, that's 298 Kelvin. But let me tell you, if you talk about the units of this particular term, since you have used the R value as 8.314, so I'll be dividing it with 1000, then only this value will come out to be in kilojoules. Now it's going to be your turn to do the calculation and get the value of delta H. Whatever delta H will be coming out to be, that is basically going to be the enthalpy of combustion at constant pressure for benzene, right? Yes? Perfect, guys. So after solving, this is the final answer which you'll be getting. Let me know in the chat if it is clear to everyone. This is the way you solve it, and final answer comes out to be minus 3267.6. Yeah? Perfect, guys? Absolutely. Wonderful. One more question, but before doing the question, if you have not enrolled into the JEE 2022 crash course batch yet, get enrolled in it as soon as possible. Trust me, this is the best and the last option for you guys to shoot up your ranks in JEE 2022. In this particular batch, till your examination, your whole syllabus will be getting covered. Apart from that test series, chapter-wise assignments, chapter-wise tests will be there, right? So basically, your master teachers in physics, chemistry, as well as mathematics. They'll be actually training you personally. They'll be guiding you personally till your JEE Mains 2022. They'll be covering your whole syllabus apart from that test series, every single thing which is needed for the competitive examination like JEE to get qualified. All those things are basically mentioned in this particular crash course. Get enrolled in it as soon as possible. Okay, as soon as possible, I'm telling you. Okay, there is one more question, my dear people. Let's try to solve this particular question. Again, the simpler one. Link to get enrolled into the crash course batch is there in the description box of the video, and at the end of the session I'll show you exactly how to get enrolled into that crash course batch which I'm talking about. See, the question says a gas expands adiabatically at constant pressure, right, such that temperature of the gas is directly proportional to what? V raised power minus 1 by 2. What do we need to calculate? We need to calculate Cp by Cv. What is Cp by Cv? That's gamma, right? Basically, we need to calculate gamma for the gas. That's it. That's what I need to do, right? That's what I need to do exactly. Temperature is directly proportional to V raised power minus 1 by 2. I need to get the value of gamma. How do I get it exactly? See, can I write it like this? Temperature is inversely proportional to V raised power 1 by 2. Or can I write it like this? TV raised power 1 by 2 is directly proportional to what? It's absolutely going to be constant, right? It's directly proportional to constant. Or I'll be writing it like this, is equal to constant. Okay. So if you look at this particular equation, then in the adiabatic processes, you have got one more equation like this. TV raised power gamma minus 1 is equal to constant. I hope you remember it. If you compare the two equations, can I say gamma minus 1 is equal to 1 by 2 basically? On comparing the equations, gamma minus 1 is coming out to be 1 by 2, which clearly tells you gamma is equal to 3 by 2. As simple as that. Gamma value is done and dusted, right? So 3 by 2 means 1.5. So option D is the one which is going to be the correct answer of this particular equation. Right, people? A very simple and basic question again. Just I converted this equation into the general form, right? And I'm sure in the adiabatic process, in the reversible adiabatic process, we have studied three equations. One is PV raised power gamma is equal to constant. Second one, TV raised power gamma minus 1 is equal to constant. Third one, P raised power 1 minus gamma, right? T raised power gamma is equal to constant. These are the three equations which we used in the reversible adiabatic processes, and over here I've used one of them, got the answer of the question, as simple as that, right? And these sort of questions are frequently asked in your JEE these days, right? Okay, moving on to one more question, my dear people. Look at the question carefully, what the question exactly says. We have got 5 moles of ideal gas expanding isothermally and irreversibly, from a pressure of 10 atm to 1 atm against a constant external pressure of this much, against a constant external pressure of 1 atm. What is going to be the value of W, right? What is going to be the value of W? Have a look exactly how I'm going to solve it. We need to calculate the value of W. It's W irreversible, right? Because the expansion is happening isothermally and irreversibly, which is mentioned in the question itself, right? W irreversible is simply going to be equal to minus P external delta V, because in case of irreversible processes, external pressure is kept constant. But at the same time, in the question, am I given with the initial or final volume of the gas? I am not given with the initial and final volume of the gas. I am given with the initial pressure and final pressure of the gas, right? So I'll be converting this particular equation into a different format. Let me convert it like this. Minus P external. Instead of V2, I'll be writing nRT divided by P2 minus, it's going to be nRT divided by P1. Since the temperature of the gas is not going to change because the process is isothermal, right? The gas is undergoing isothermal process, so temperature is remaining constant. So it's simply going to be equal to minus P external, then you'll be writing nRT, then you'll be writing 1 upon P2 minus 1 upon P1. This is the equation which I'll be using. Let's put all the parameters into this particular equation. Minus times P external. External pressure, as per the equation, is given to us as 1 atm. Right? It's given to us as 1 atm. N value, number of moles, 5. 5 moles of gas. Right? Value of R, 8.314 joules per Kelvin per mole. Temperature of the gas is given to us. It must be given to us, right? Where is the temperature given? It's 300 Kelvin. Okay. 1 upon P2, final pressure of the gas, which is 1 atm. Initial pressure of the gas, which is 10 atm. So when you put all these parameters into this particular equation, you'll be getting the answer in joules. But do I need the answer in joules or kilojoules? I need the answer in kilojoules, I guess, right? So simultaneously, I'll be dividing it with 1000, then only I'll be getting the answer exactly in kilojoules, right? Now, it's going to be completely your job to do this much of calculation, get the answer, get the value of W, which I was supposed to calculate. I'm sure it's clear to every single guy. Right, people? Perfecto. All right, so let's move on to one more question. Very, very simple and basic question again. For 1 mole of ideal gas, we are given with 1 mole of ideal gas. For 1 mole of ideal gas, a curve between internal energy versus temperature is given. Internal energy versus temperature curve is given to us, right? Identify at which point A or B CV value will be highest. We need to see at what point A or B CV value will be more. I'm sure every one of you would have studied this particular equation, du is equal to n CV dt, right? Which is followed by the ideal gas, right? For an ideal gas, internal energy change is always equal to n CV dt, right? Small internal energy change is always equal to n CV dt, right? When CV is independent of temperature. Perfect. Now, since we are given with 1 mole of ideal gas, so n value is going to be 1. If n value is 1, can I say CV is basically equal to du upon dt? What is du upon dt? du upon dt is nothing that is basically the slope of, internal energy versus temperature curve. That is basically the slope of internal energy versus temperature curve. So can I say wherever the slope of internal energy versus temperature curve is more, there only CV value is going to be more. Now basically at point A and point B, I need to check the slopes. So I'll be drawing a tangent over here, right? Which for example makes the angle theta A with the positive x-axis in the anti-clockwise direction. I'll be drawing one more tangent over here, which is for example making theta B with the positive x-axis in the anti-clockwise direction. So can I simply say theta A is greater than theta B? Theta A is greater than theta B. And people, if theta is greater than theta B, I can clearly say tan of theta A again is going to be greater than the tan of theta B, right? Which clearly tells you slope at A is greater than slope at B. If slope at A is greater than slope at B, what does that mean? That means CV at point A is definitely going to be greater than that of CV at point B. There's something which I wanted to check, right? CV at A will be more. Perfect. Very simple and basic. Let me know in the charts if it is perfectly understood. Yes, Monisha, you're right. Let's quickly move on to one more question, my dear people. The question says 1 mole of ideal gas whose CV value is given to us, right? At 300 Kelvin and 5 atm is expanded adiabatically to a final pressure of 2 atm against a constant external pressure of 2 atm. Find the temperature of the gas. We basically need to calculate the final temperature of the gas. T2 value we need to calculate. Let me write all the parameters which are given to us basically. Say, N value, number of moles of the ideal gas, it's given to me as 1. We have got the ideal gas whose CV value is given to us as 5 by 2R. Right? The initial temperature of the ideal gas was 300 Kelvin. Right? The initial pressure of the ideal gas was 5 atm. After the expansion is done, the final pressure of the ideal gas, which I represent with P2, is equal to 2 atm, right? Against a constant external pressure of 2 atm, P external is given to us as 2 atm. What do I need to calculate exactly? I need to calculate the final temperature of the gas, T2, right? If you look at this particular equation, the expansion is happening adiabatically against a constant external pressure. Expansion is happening adiabatically against a constant external pressure. So this expansion is basically going to be irreversible adiabatic expansion. It's going to be irreversible adiabatic expansion. And you know, in adiabatic processes, Q value is 0. If Q value is 0, I'll say as per first law, delta U is equal to Q. Sorry, delta U is equal to W because Q value is 0. But which W right now? It's W irreversible because it is the irreversible adiabatic expansion of the ideal gas. As simple as that. This is the equation which I'll be using. By solving this particular equation, I will be getting the final temperature of the gas. And how come? Have a look. Delta U for the ideal gas, it's equal to NCV T2 minus T1. Every one of you will be knowing this. W irreversible, it's going to be minus P external V2 minus V1. But I'm not given with the initial and the final volume of the gas. So what I'll be doing, I'll be converting these terms into the pressure form. And how come? See, N value is given to me as 1. CV value is given to me as 5 divided by 2R. T2 minus T1. T2 is the final temperature of the gas which I need to calculate after the expansion is done. Minus T1 is the initial temperature which is equal to 300 is equal to minus times P external. External pressure is given to me as 2 atm, right? V2, final volume of the gas. As per the ideal gas equation, I can write it as nR T2 divided by P2 minus nR T1 divided by P1. Perfect. N value is given to me R value gets cancelled out from both the sides. This is R, this is R, this is R, R gets cancelled out. T2 I need to calculate. T1 is given to me, P1, P2 is given to me. All these parameters are given to me basically. After putting all these parameters into this particular equation, you will be getting one equation which just contains one unknown. And after solving this particular equation, you'll be exactly getting the final temperature of the gas, which exactly I was supposed to calculate, right? Do not use the equation. Do not use the equation T1 V1 raised power gamma minus 1 is equal to T2 V2 raised power gamma minus 1 in this question. Why is that? Because this is the equation which is basically valid for reversible adiabatic processes. It is not valid for irreversible adiabatic processes, right? Do not use this particular equation. This particular equation is used to calculate the final temperature of the gas in case of reversible adiabatic processes, not in case of irreversible adiabatic, right? I'm sure from now onwards you can easily solve these sort of questions. I'm sure about that. Moving on to one more. So after solving the equation, you get the final answer as this much, as you can see, right? Whatever things I've done till now, all those things are mentioned over here. Yeah? Okay. Moving on, people, to one more question. This is one more question, and these sort of questions have many a times been asked in your JEE examination, and I'm sure you can easily solve these sort of questions. See, guys, we have got 1 mole of non-ideal gas. Okay, it is a real gas, right? It is a real gas. 1 mole of non-ideal gas, basically 1 mole of real gas, okay, undergoes a change of state from 1 atm 3 liters 200 Kelvin to 4 atm 5 liters 250 Kelvin. With the change in internal energy as 40 atm liter, the change in the enthalpy of the process will be, okay, change in enthalpy we need to calculate, okay. A simple question, people. I hope you know the general relation, that is delta H is equal to delta U plus delta of PV. This is the general equation which is valid for your ideal as well as non-ideal processes, non-ideal gases, sorry, right? Now, people, since, as you can see, when the system was at initial state, its pressure was 1 atm. When the system is at final state, its pressure is 4 atm. When the system was at initial state, its volume was 3 liters. When the system is at final state, its volume is 5 liters. So pressure as well as volume is changing. Pressure as well as volume is changing. So I'll be using the equation delta U. Instead of delta PV, you'll be quickly writing as P2 V2 minus P1 V1 because pressure as well as volume is changing, right? As simple as that. Now I need to calculate the value of delta H. Delta U is given to us as per the equation 40 atm liter plus P2 V2. This is P2, this is V2, 5 4 20, right? Minus P1 V1. This is P1, this is V1, which is 3, right? So 40 plus 17 comes out to be what? It comes out to be 57, and the units are again going to be in atm liter. So this is basically the value of delta H, which exactly I was supposed to calculate. So it's basically option B, which is coming out as the final answer, right, people? A very simple and basic question again. I'm sure you can solve these sort of questions from now onwards. Let's quickly move on to one more question then. This is one more question. Let's try to solve these sort of questions as well. The question says, calculate delta U when 2 moles of liquid water vaporizes at 100 degrees centigrade. So basically, I'm vaporizing H2O, right? I'm vaporizing H2O. That means H2O liquid will be getting converted into H2O gas. Heat of vaporization is given to us. Delta H during this process, which we call as enthalpy of vaporization, is given to us as 40.66 kilojoules per mole. What do I need to calculate exactly? I need to calculate the value of delta U. Delta U is something which I need to calculate. Perfect. How to tackle this sort of question is again simple. First thing, I'll be calculating delta Ng for this particular reaction. Delta Ng for this particular reaction is going to be number of moles of gaseous products, which is 1, minus number of moles of gaseous reactant, which is 0. So delta Ng is 1. If delta Ng is 1, I'll be using the relation delta H is equal delta U plus delta Ng RT. Right, people? So from here, I will be getting the value of delta U, which is delta H minus delta Ng RT. Now, people, delta H. Delta H is given to us as 40.66 kilojoules, right? Minus delta Ng value, that's equal to 1. R value, 8.314. Temperature, 100 degrees centigrade, which is 373 Kelvin. Divided with 1000. Why is that? Because you want this term to be in kilojoules as well, right? So from here, you will be getting the value of delta U, right? And as far as I remember, the value of delta U comes out to be 37.5 kilojoules. So if the value of delta U comes out to be 37.5 kilojoules, is it going to be option A as the answer? No way. Why is that? Because this is the value of delta U when 1 mole of liquid water undergoes vaporization. But am I doing the vaporization of 1 mole of liquid water? No way. We do the vaporization of 2 moles of liquid water. This is the value of delta U for the vaporization of 1 mole of liquid water. So for 2 moles of liquid water, you need to multiply it with 2, right? So on multiplying it with 2, the value comes out to be 75.1 kilojoules, right? This is the value of delta U when we do the vaporization of 2 moles of liquid water. I'm sure this sort of equation you can solve from now onwards, right? One more particular question, right? I'm sure you can easily solve this particular question as well. Again, based on the relation between delta H and delta U. The reaction is given to me, and the reaction is given to me in the balanced form, right? So first thing which I'll be doing, I will be calculating the value of delta Ng for this particular reaction. It's going to be equal to number of moles of gaseous products, which is 1 plus 1, that's 2, minus number of moles of gaseous reactants, which is 3 by 2. So 2 minus 3 by 2 comes out to be 1 by 2. Right? It comes out to be 1 by 2. Delta Ng we have calculated. Now you're simply going to use the relation delta H is equal to delta U plus delta of Ng multiplied by R multiplied by T. What do I need to calculate? I need to calculate delta H. Delta H I need to calculate in what? In kilojoules. Perfect. So delta U, it is given to us in kilojoules only, which is minus 742.7 kilojoules. Right? Now people, delta Ng value, it's given to us as 1 by 2. R value, 8.314 joules per Kelvin per mole. Temperature of the system, it's given to us as how much? 298. Okay, now I'll be dividing it with 1000 as well, because this term has to be in kilojoules, right? So I've divided with 1000, then only this term will come in kilojoules. So from here, you'll be getting the value of delta H, I'm sure, right? And easily you can solve it afterwards and get the value of delta H, which comes out to be 741 point something over here, right? I'm sure these sort of questions you can easily solve from now onwards. The solution is given. It will be provided to you in the Telegram group in the form of PDF, right? No need to worry about that. This is one more question. Let's try to solve this particular question as well. The question says 5 moles of N2H4 liquid undergoes complete dissociation at 27 degrees centigrade. Determine work done in calories. I need to calculate W. Right? We are doing the decomposition of what? N2H4. The reaction is given to us, right? Which expression I'll be using? I'll be using W is equal to minus delta Ng RT. As simple as that. Yeah? Let's try to use this expression to calculate W. First thing, what is the value of delta Ng for this particular reaction? It's going to be equal to number of moles of gaseous products, which is 4 plus 1, 5, right? Minus number of moles of gaseous reactants. There is no gaseous reactants, so delta Ng is 5 quickly. So W value will be equal to minus times delta Ng is 5. R value is 2 calories per Kelvin per mole, because I need to get the answer in calories. Temperature of the system is given to me in degree centigrade, so make it in Kelvin, so 300. Perfect, 300 Kelvin. So 5 to 10, the value comes out to be minus 3000 joules. Sorry, 3000 calories. So if I ask you, is this minus 3000 going to be the correct answer of this question? No way. This is basically the value of W when we do the decomposition of 3 moles of N2H4. When we do the decomposition of 3 moles of N2H4, what is the value of W? It's minus 3000 calories. Right? So when we do the decomposition of 1 mole of N2H4, right, what is going to be the value of W? It's going to be minus 3000 divided by 3. The value comes out to be minus 1000. Right? This much work is done by the system. This 1000 calories of work is done by this system when we do the decomposition of 1 mole of N2H4. But are we doing the decomposition of 1 mole of N2H4? No. We are doing the decomposition of 5 moles of N2H4. So for the decomposition of 5 moles of N2H4, so you need to, this is going to be the value of W. So multiplied with 5. The final value comes out to be minus 5000 calories. So this much work, 5000 calories of work is done by the system during this process. So the answer of this particular question is going to be option D. Right? I'm sure from now onwards you can solve these sort of questions. Right, people? Perfecto? Absolutely. Let's move on quickly to one more. This is one more question, very simple, right? Which of the following set of parameters that represents path functions, heat and work? Q is a path function, W is a path function. Q path function, W path function. Q plus W is the internal energy, that's a state function. H minus Ts, that's Gibbs free energy, that's a state function. So A and D, these are state functions, whereas B and C, Q and W, these are the path functions. So it's going to be B and C are the path functions, so option D is the one which is correct, right? Option D is the correct answer of this particular question. One more simple question, people. The question says a gas present in a cylinder fitted with a frictionless piston expands against a constant external pressure of 1 atm. So the process is irreversible because expansion is happening against constant external pressure. And what is the constant external pressure? It's 1 atm. right? From the volume of 2 liters to 6 liters. So V1, initial volume of the gas is equal to 2 liters. Final volume of the gas is equal to 6 liters. In doing so, when this expansion is happening against the constant external pressure, in doing so, the gas is absorbing 800 joules of heat. The gas is absorbing heat, so Q value is going to be positive, right? Plus 800 joules. What do we need to calculate? Delta U. Simple, the equation is based on first law of thermodynamics. Delta U, I need to calculate in joules, right? Is equal to. Delta U is simply going to be equal to Q plus W, right? So Q value as per equation is given to us as plus 800 joules. Plus W is simply going to be equal to minus P delta V because the process is irreversible, external pressure is constant, right? So minus times P. P external is 1 atm, right? V2 minus V1, 6 minus 2, 4, right? This term comes out to be in atm liter, but I need it in joules, so I'll be multiplying it with 101.3 as well. Then only the answer finally comes in joules. Just solve this equation from here, get the value of delta U. That's something which I was supposed to calculate, and the final answer after solving the equation comes out to be exactly as 394.7 after solving that equation which I gave you. One more question, simple and basic. I'm sure you can easily solve it. We need to calculate W, right? An ideal gas is showing expansion against constant external pressure, my dear people, right? So the process is irreversible. So W value is simple, calculated by the formula minus P external V2 minus V1, right? So W irreversible is simply going to be equal to minus P external. It's going to be V2 minus V1, right? Minus times P external. P external is given to us as 10 raised per 5 Newton per meter square, right? V2 is which is the final volume. Final volume is 10 raised per minus 2 meter cube minus initial volume, that's 10 raised per minus 3, right? So what is the final answer which will come out from here? 10 raised per 5. The answer is going to be in joules because you have used everywhere the SI system. You have used everywhere as the SI units. So the answer of W will come out in SI units as well, right? That's going to be in joules. So over here, what I'll be doing, I'll be taking the smaller one as common, which is 10 raised per minus 3. This one is going to be 10 raised per minus 2 divided by 10 raised per minus 3 minus 1, right? So this term over here will come out to be minus times 10 raised per 2, right? It's going to be 10 minus 1, that's 9. So the final answer of this question is going to be minus 900 joules. So W value came out to be minus 900 joules, right? So the answer of this particular question is option A. I'm sure you can easily solve these sort of questions again. The process was irreversible, external pressure is kept constant, so that's why I used this relation. If it was reversible, then I would have used this equation. Minus integral V1 to V2, it's going to be P gas multiplied by dV. If the process was reversible, then I'm saying, yeah? Yes, Sucharita, yes, absolutely. These are the mains level questions. Okay, one more question we have. Let's try to solve this particular question as well. Let's exactly see how do we solve this. 1 mole of aluminum is dropped in an aqueous solution. Aluminum is dropped in an aqueous solution in an open container. That means pressure is constant. It's a constant pressure process. I'm sure you know the open vessel concept, right? So the process is going to be isobaric first thing. The process is going to be isobaric. Whenever in a question it's mentioned that it is the open vessel concept, that means you will be directly taking the pressure as constant. You'll be considering the process to be isobaric, right? Do remember it from now onwards. Now people, if 95 calories of heat is released, so this much amount of heat is being released at constant pressure, right? Heat released or absorbed at constant pressure is basically QP, which is delta H, which will be equal to minus 95 calories. Why minus? Because heat is being released, right? Because heat is being released. Yeah, as simple as that. This much amount of heat is being released, 95 calories of heat is being released during the process. So basically heat is being released at constant pressure. Heat released or absorbed at constant pressure is represented by QP, which is always equal to delta H, correct? What do I need to calculate? I need to calculate W, I need to calculate delta U, delta H, right? Delta H we already got. Delta H we already got. W value is simply going to be equal to minus delta NGRT. This is the formula which I'll be using, simple, right? So W is going to be equal to minus times delta Ng. Number of moles of gaseous products, which is 3 by 2, minus number of moles of gaseous reactants, no one. So delta Ng is nothing, that's 3 by 2. R value in calories is going to be 2 calories per Kelvin per mole. Temperature of the system is 300 Kelvin, right people? So this is 1, I mean, this 2 got cancelled out. So W value is simply coming out to be minus 600 calories. This is the value of W which we were supposed to calculate. This is the value of W which we are supposed to calculate, right? W value we got. Now delta H also we got. Now the point is how to calculate delta U. You know the relation. Delta H is equal to delta U plus delta NGRT, right? See, delta H is given to you, delta Ng you know, R value 2 calories per Kelvin per mole, temperature is given to us 300 Kelvin. So from here you can easily calculate delta U. I'm sure it's clear, right? And after solving all the things, you'll be getting the final answers as W value you got as minus 900. Is that? I think we got the same, minus 900, right? Did I write 600? Did I write 600? So I multiplied it like this. 3 multiplied by 300 is 600. Wow. So it's 900, right? Okay. So this is one of the way by means of which you can get delta U, or you'll be using the equation delta H is equal to delta U plus delta NGRT. That's all, right? Perfect. Let's move on to one more. This is one more question. This is a bit lengthier. See guys, how do we tackle to these sort of questions, right? This question was asked long back in advanced ones. The question says, we have got 1 mole of gas A whose CV is given, 2 moles of gas B whose CV is given. They are mixed in a container, right? So basically, you have got a container which contains 2 gases, gas A and gas B. Or let me call them as gas 1, gas 2. You have got 2 gas in the container, gas 1 and gas 2. Well, CV for gas 1 is given to us as 3R. CV for gas 2 is given to us as 3 by 2R. Right? 3 by 2R. Are mixed in the container, expanded adiabatically and reversibly. So we have got a mixture of gas. The volume of this mixture initially was 1 liter. Volume of the gas finally after the expansion is coming out to be 4 liters. Right? And as per the question, people, as per this particular question, as per the question, what is mentioned, we have got a mixture of gas which is undergoing expansion from 1 liter to 4 liters, right? And the expansion is happening adiabatically and reversibly, right? Initial temperature of the gas is given to us as 320 Kelvin. What do we need to calculate? I need to calculate the work done during the process. So when the mixture of gas right now is undergoing expansion from 1 liter to 4 liters, reversibly and adiabatically, what is the work done during the process, right? So how do we calculate work done during reversible adiabatic expansion? If you remember, work done during reversible adiabatic expansion, that's always equal to delta U, and delta U is equal to N CV delta T, which is T2 minus T1. Perfect. Now people, N value number of moles, total moles present in the mixture we know. CV, this is the CV for the mixture. So basically I need to calculate the CV for the mixture first. So CV for the gaseous mixture, you guys know it, it's going to be equal to N1 CV1 plus N2 CV2 divided by what? Divided by N1 plus N2. Well, I think you know all the parameters. N1 value, number of moles of the gas, A, that's 1. Multiplied by CV1, that's equal to 3R, right? That's equal to 3R. So N1 CV1, simply I'll be writing 3R plus N2 CV2. N2 CV2, it's going to be 3R by 2 multiplied by 2. So again it comes out to be 3R divided by N1 plus N2. 1 plus 2 comes out to be 3. So 3 plus 3, 6R divided by 3. That means 2R. So CV value for the mixture is coming out to be 2R. Right, people? Now, people, you know CP minus CV is equal to R. So I'll be writing CP mixture minus CV mixture. CP mixture minus CV mixture is simply going to be R. Right? So I will be getting CP mixture from here as well. So CP mixture is going to be equal to R plus CV mixture, which comes out to be 3R. Well, if you got CP mixture, if you got the CV mixture, can I calculate gamma over here? Which is going to be equal to CP mixture, 3R, divided by CV mixture, that's 2R. The value comes out to be 1.5. You got the value of gamma? You got the value of gamma. Why did I calculate all this? Why is that? Because I will be calculating the final temperature as well. Because I need to calculate final temperature. Because final temperature I need to use in this particular equation. I'll be now using the equation T1 V1 raised power gamma minus 1 is equal to T2 V2 raised power gamma minus 1, because the process is reversible adiabatic, right? T1 is given to us as 320. V1 initial volume 1 raised power anything is 1 is equal to T2 multiplied by V2. V2 is 4 liters raised per gamma minus 1. Gamma is 1.5. 1.5 minus 1 is 0.5. 0.5 means 1 by 2. So from here, T2 value you got to know as 160 Kelvin. This is the final temperature. I got the final temperature as well. So I'll be now using the expression to calculate work done during this reversible adiabatic expansion. It's going to be equal to N. Total moles present in the mixture. 2 plus 1. That's 3. Right? CV for the mixture. We calculate that. That's 3R. 3 multiplied by R. R is 2 calories per Kelvin per mole. Right? Okay. So this is N. This is CV. T2 minus T1. T2 is the final temperature of the gas, which is 160 Kelvin. Initial temperature of the gas is 320 Kelvin. So the final value in calories you will be getting as 3399218, right? 3399218 multiplied by what? 18 multiplied by minus 160. Just solve it, get the answer exactly in calories, right? Perfect, guys. I'm sure it's clear to everyone, right? Should I be moving on to one more? Right, people? Okay, I took the value of CV as 3R, right? But CV we have calculated as how much? CV is 2R. So this is 2R. So just remove this 3, make it 2. Now it's fine. Okay, so the answer is finally going to be 3 to 6, right? 6 to 12. So it's going to be 12 multiplied by what? 12 multiplied by minus 160 calories. Now it's fine. Yeah? Perfect. Let's move on. This is one more question, and let's have a look exactly what is asked in the question. It's a simpler one, I believe. A piston filled with these many moles of gas expands reversibly from these many ml to this one at constant temperature. As it does so, it absorbs 208 joules of heat. The value is Q. See, guys, it's very simple. As per the question, the process is isothermal, right? The process is isothermal because the expansion of gas is happening at constant temperature. The process is isothermal. If the process is isothermal, delta U for the ideal gas which undergoes isothermal process, that's always equal to 0. So as per first law, your Q is simply going to be equal to minus W. Well, you know, Q value, the system is absorbing heat. As per the question, the system is absorbing 208 joules of heat. When the system absorbs heat, Q value positive, right? If Q is positive, W is simply going to be equal to minus 208 joules then. Because you know, for the isothermal process, Q is always equal to minus W. So find the options. Q is plus 208, W is minus 208. That's it. Option A. Simple. Right, guys? Okay, this is one of the questions. This is one of the questions which I'm giving you as the homework. Do give it a try and let me know the answer of this particular question in the comment section of the video, right? This was your homework question. Very simple, based on the Gibbs free energy, right? Solve it and do let me know its answer in the comment section, my dear people, right? Okay. Have a look now. Look at this particular question. This is something which you can solve without using the pen and paper. I'm sure about that. The internal energy change when the system goes from A to B is this much. If the system goes from A to B by reversible path and returns to A by irreversible path, what is the net change in internal energy? Internal energy is a state function, right? Internal energy is a state function. For any cyclic process, change in the value of state function is always 0. Perfect. So delta U for this particular cyclic process is absolutely going to be 0. It's going to be path independent, right? So answer of this particular question is simply going to be 0. That's it. Right? For isothermal expansion of the ideal gas, whenever the ideal gas undergoes isothermal expansion or isothermal compression, or in short, I'll say whenever the ideal gas undergoes isothermal process, its delta U is simply going to be 0. Its delta H is also going to be 0. You know, delta G is equal to delta H minus T delta S. Delta H is 0, so delta G is simply going to be equal to minus T delta S, right? Delta G is simply going to be equal to minus T delta S. I'm sure you can solve this sort of question. I mean, this question is solved already. Yeah? Okay. One more question, my dear people. Calculate the entropy change involved. We are supposed to calculate entropy changed in the conversion of 1 mole of solid ice. 1 mole of solid ice at 273 Kelvin to liquid water. Perfect. So you need to calculate entropy change during this process, right? I'm sure you can solve it on your own. Perfect. It's simply going to be equal to dq reversible upon t. dq reversible is basically going to be your delta H for this particular process, and which is given to us 6025 joules per mole divided by t. T is given to us as 273. So just solve it, get the value in joules per Kelvin. That's it. Right? Get the value in joules per Kelvin. Because you know, delta S for fusion is nothing. That's equal to delta H for fusion divided by fusion temperature divided by melting point, you can say. One more question. This again going to be one of your homeworks. Do give it a try. So people, with this, I am going to take a leave. But the two questions which I gave you as the homework, please and please do give it a try and let me know their answers in the comment sections of the video, right? And you know, your dates, your JEE Mains 2022 dates are out, right people? So the best option for you guys right now to shoot up your rank, is going to get enrolled into the JEE 2022 crash course batch, which we are starting on the actual on the platform, in which the best teachers of Vedantu will be training you in all the subjects, physics, chemistry, as well as mathematics. So before your JEE Mains examination, your whole syllabus will be getting covered, right? It's not only about the course completion. No need to worry about the assignments. No need to worry about the test series, right? No need to worry about the chapter-wise assignments, chapter-wise tests, right? Every single thing is included in this particular JEE 2022 crash course batch. Okay, and this is completely affordable. If you use this coupon code, it's just going to be for 8K. So in just 8K, your whole syllabus in all the subjects is getting covered by the teachers, by the best teachers on the actual on the platform. Apart from that, test series is included. You'll be getting the study material, every single thing which is needed for the competitive examination, like NEET, like JEE to get cracked. All those things are included in this basically crash course. So do get enrolled. It's my personal suggestion for you guys, because this is the best and the last option for you guys to shoot up your ranks in your JEE examination, right? Do get enrolled in it. Trust me, it's going to be highly, highly beneficial. I've seen people getting enrolled into the crash course batches, shooting up their ranks like anything. Okay, so how to get enrolled exactly into this particular crash course batch? This is the video which you guys are currently watching, right? Just drag the video a little down, click on show more. After clicking on show more, click on JEE crash course, right? Click on this link. When you click on this particular link, just drag it a little down, click on buy now, and after clicking on buy now, put your number, email ID, right? You'll be automatically getting enrolled into the batch, into the JEE 2022 crash course batch, right? Which we have started on the actual on the platform. Perfect. So get enrolled in as soon as possible if you really want to improvise your ranks. Your master teachers, right? They'll be exactly starting from the basics and scaling it up to your mains level for sure. All the problem patterns in your physics, chemistry, mathematics will be done and dusted by the master teacher itself. After every chapter, you'll be provided with the assignment. You will be supposed to submit that assignment through online mode, by means of which you can, after knowing the result of that particular assignment, you will be exactly getting to know about your weaknesses, about your strengths, about the things where you need to work more, right? Yes, so all the things are basically all the things you'll be getting after getting enrolled into this particular crash course batch which I'm talking about, right? So Shakir has already enrolled. That's great. That's wonderful. So I'm talking about the ones who have not enrolled into this particular crash course batch yet. So do get enrolled as soon as possible, right? Trust me, the best and the last option for you guys to score up your ranks. Okay, right? So with this, people, I'm going to take a leave. If you're not liked the video yet, please do like the video, share the video with your friends, and do subscribe to the channel as well. It was nice meeting you. See you tomorrow. Take care. Bye-bye. God bless you all. Take care, guys. Bye.